Hi everybody, I'm Blaise Stefanik and I'm a solutions architect with AWS. I've had the pleasure of working with our customer FINRA for the past year, and I'm excited to be co-presenting with two of their champions of innovation at FINRA. FINRA's team has a really great story to tell, and it's about how they were challenged by their investigators to come up with a solution that helps them identify potential fraud in the financial markets. Uh, Today, I'll first be giving background on knowledge graphs, then I'll give an overview of Amazon Neptune, and then integrations with Amazon Neptune, which include a solution for unstructured data by using AWS services such as Amazon Textract and Amazon Comprehend. Then Shagata and Dimitro will be telling their story about how this all applies to FINRA. They'll give an overview of the work that FINRA has to perform and the business insights that they gain by using Amazon Neptune, and ultimately their lessons learned and their trajectory on their path forward. Many things in the world are highly connected, and graphs really present relationships that are all around us in a format that's really easy to understand. The graphs consist of nodes and links, and they represent relationships between things. So this illustration depicts a data set consisting of air routes. The green circles represent airports and are our nodes, and the yellow lines represent scheduled flights between the different nodes, which are our links. It's taken from a data set that was developed by one of our solution architects, Kelvin Lawrence, and we use this as an example later on. Customers often ask us, when should I use a graph database? And you should use a graph database if you have a large amount of relationships within your data that are just as important as the data itself. And you want to ask questions about that data which involve traversing those relationships, or you want to express patterns within those relationships. So in healthcare and life sciences, we see customers using Neptune for things like drug discovery, as well as identifying disease and gene relationships. So what kind of problems and classification of problems do we see our customers using graphs for? There are really three types. So first, there are knowledge graphs, which are a way to organize and structure information for better access and understanding. For example, you might use knowledge graphs for network IT operations. With Neptune, you can store, process billions of events and really help to secure your network. You also have fraud graphs. For example, you may want to discover the footprint of a bad actor who might be going in and using the same credit card and email account as a known fraud case. And then the third type of graphs, you have identity graphs, and they really help you understand your customers better, such as giving them recommendations based on their interests or based on their friends or purchase history. Amazon Neptune is our purpose-built high-performance graph database which is optimized for processing graph queries. For example, read capacity can be scaled to support execution of more than 100,000 graph queries per second. But you can start small and then you can easily scale up as you need to. Amazon Neptune supports Open Graph APIs for both Common Graph data models, which include Tinkerpop and RDF, which you can use with Gremlin and Sparkle, respectively. With Amazon Neptune, you don't need to worry about database management, such as backups and things along those lines. And Amazon Neptune also is designed to provide greater availability with 99.99% availability SLA. It features fault tolerance, self-healing storage, as well as point-in-time recovery. So lastly, Neptune provides multiple levels of security for your database, which include network isolation with Amazon VPC. Neptune is available in 21 AWS regions, which are listed on the slide. For encryption at rest, Neptune uses keys that you can create and control using AWS Key Management Service, or KMS. The underlying storage, the automated backups, the snapshots, and replicas for those encrypted Neptune instances are also encrypted with the same key. For encryption in transit, Neptune provides HTTPS encrypted client connections. And Amazon Neptune is in scope for different compliance programs that we have, including SOC, and it's one of our HIPAA eligible services, PCI DSS, as well as ISO. Since its launch in May of 2018, the Neptune service team has really been innovating in three main categories that they focus on. There's cost and performance, enterprise capabilities, as well as integrations and machine learning. So this slide's really intended to show all of the great things that they've built. I don't intend to dive deep into every single one, but Neptune provides customers with the ability to really pay for what they use, and ultimately, operate at a production scale with enterprise capabilities, really easily ingest data, and then also integrate with the greater AWS ecosystem. So to demonstrate one of the key innovations which has come recently, new in November of 2020, Neptune ML was released to help make predictions based on your graph data without any machine learning experience required. So it's powered by Amazon SageMaker and Deep Graph Library, and ultimately helps you make predictions on your existing graph data across billions of relationships that you might have, and many more that come in on a daily basis. So to understand the challenge with unstructured documents, I want to quickly talk about how Neptune ultimately stores graph data. So this is an example of the air routes dataset, which we visualized in the graphic earlier. And you can see the nodes and routes and the airports and the different scheduled flights. And in this dataset, these represent the airport codes and the different scheduled flights which would be going out between them. So if you want to find one-stop connections, say from Seattle to Frankfurt, you would set one as your target, the other one as your destination, and say, based on these two things, find all of the one-stop connections. Neptune provides the ability to use two data models, both Tinkerpop and RDF. Depicted is a representation of the same air routes dataset that you use, but ultimately you can see that the dataset is set up in a 4-position element, or what's called a quad. And this consists of a triple, which is your subject, predicate, object combination, plus you have a named graph identifier. So the structure is important for understanding ultimately how we go from a document into what we need to actually ingest into Amazon Neptune. So I want to cover a few integrations which really make it easy to ingest structured data prior to getting into the unstructured. The first is Amazon Kinesis. So we provide multiple integrations which are available on our AWS service, or AWS samples GitHub. And with Amazon Kinesis data streams, we can continuously capture, say, gigabytes of data from hundreds of thousands of sources all at once. And those might be website click streams, financial transactions, and things along those lines that's streaming in this data. Ultimately, customers can format that structured data into quads and then ingest it into Amazon Neptune. AWS Database Migration Service is a service that we've built which helps migrate databases to AWS quickly and securely while the source database remains fully operational. So it integrates with most of the widely used and commercial and open source databases, such as Microsoft SQL Server, Oracle, MySQL, etc. And with the DMS integration with Neptune, customers can copy relational data into Neptune and really create graphs that come from multiple sets of databases within your organization. So the integrations can be great, but what do customers do if we have a stack of papers on our desk and we really want to get all the information out of there? So the first step is really extracting the data from the documents. And the ways which companies process documents today often come with a lot of challenges. So the first way is human intervention. So I might go into a file, scan through it, enter values into an application, and hopefully hit save and not forget to. Extracting data manually is expensive, error-prone, and ultimately time-consuming. And a common approach that we see are either template-based or using optical character recognition, or OCR. And we found that this is extremely limiting and often tedious. There are two main issues there, right? So one is that not everybody knows machine learning, and the other one is that they can be very temperamental if you switch away from that particular template that you're using. So Amazon Textract is a fully managed machine learning service that automatically extracts text from documents. It requires no machine learning expertise whatsoever, and it's effectively an API where you send in a document and it returns the proposed text that it finds along with a confidence score. So Amazon Textract can help you extract data quickly and accurately and really help you scale and automate your document workflows. So it makes the manual effort a lot less by, instead of templates, is using machine learning under the hood. And if the confidence score is lower than a particular threshold, you can also have a human in the loop with SageMaker Augmented AI, or A2I, to then review the extracted data. So it's like you have a first pass from Amazon Textract, and then you have a human double checking the work that the AI has done. Then we also have Amazon Comprehend, which is really the next step in that workflow. So we've extracted that text from the document, and now we want to do something with it and identify the entities and relationships. Comprehend is a natural language processing service which can help you find insights and relationships within your own structured data. And just like with Textract, Comprehend requires no machine learning expertise to get started. It's really an API where you send in the text, which could have come from Textract, and then it provides back data based on pre-trained models or custom entities that you've created and trained your models with within Comprehend. This is an example of entity detection and detecting the different types of those entities. So by doing this, Comprehend helps us to define the triples and the quads consumable by Neptune downstream. So with Textract and Comprehend, you ultimately can input documents and output the triples. Textract and Comprehend can both be used within your network with network isolation with Amazon VPC and encrypted with Amazon KMS. So ultimately, FINRA investigators can go into their application and perform investigations faster and with a higher accuracy. Meanwhile, on the back end, FINRA is able to take their documents, extract the text with Amazon Textract, extract the entities and relationships with Amazon Comprehend, assemble the triples, and store the data in Amazon S3, at which point then they can actually enrich the data by adding additional triples through data that's in their private databases. Ultimately, they submit that data into Amazon Neptune, and then they also use Amazon Neptune Streams to put that data into Amazon Elasticsearch Service, which allows them to index that data and allows for the ability to have natural language search capabilities on top of that data. So business users can now easily gain more accurate insights from the stack of documents that were once on their desk. So it's my pleasure to pass it over to FINRA's technology leaders, Shagata and Dimitri.
Hello, I'm Shagata Chakraborty, Senior Director at FINRA. Today, my colleague Dimitri and I are going to discuss how FINRA is using AWS technologies such as Neptune in our regulatory mission. So let's start with looking at FINRA's regulatory mission. FINRA is a self-regulatory organization of about 3,500 plus brokerage firms and about 600,000 plus brokers. If you have a brokerage account, your brokerage firm is a member of FINRA and is regulated by us. Our mission is to make sure that across the nation, investors stay protected and the markets stay fair so that all investors, including you, have the confidence to trade in the markets. We deter misconduct in the markets by the brokerage firms and the brokers by enforcing federal securities rules, FINRA rules, and various other rule sets. We detect wrongdoing, such as insider trading and money laundering. And when we do find misconduct, we take action against the offenders. Now, to enforce the compliance with rules, we collect a variety of data from our member firms, both structured and unstructured. And over time, the volume of data has gotten overwhelming to be able to analyze using traditional approaches. So our enforcement department came to us and explained a live case where a team of very dedicated and senior investigators uncovered a trail of evidence after months of sifting through data sets and stitching together a picture of wrongdoing. And they challenged us to use advanced technologies to replicate the same trail of evidence and find the same issues and uncover the connections. And you are familiar with this kind of connections, the web, through detective series and detective movies where you see various people in a team coming together with pieces of evidence and trying to stitch together this entire big picture. Let's look at the trail that they asked us to find. Among the thousands of documents that they looked at during this case, one was a stock certificate belonging to a John Doe for Acme Corporation. When they looked into the ownership of the certificate, they found that John Doe was an insider at Acme Corporation for which he owned the stock. When they looked into his brokerage account, they found that he had transferred some of these stock to somebody, a Ms. Doe, who could be looked at as a relation. When they looked at the brokerage account of Ms. Doe, they found that she had sold some of the shares right about the time when there was some news in the market that affected the price of the share. So this overall picture started raising a suspicion about the environment that's at this firm. Is it a case of insider trading? When we were challenged to uncover this trail of evidence, we were told, wouldn't it be really efficient if you have advanced technology that can process all these data sets, the news articles, everything that we have in FINRA about this firm and this brokerage, and present this in a visually rich UI for our investigators to conduct the analysis? And that's what we did. And we not only found the evidence that we were challenged to find, we found more of it. And to tell us how we did it, I'm going to turn it over to my colleague, Dmitry.
Thank you, Shagara. My name is Dmitry Dolgopolov. I'm Senior Director at FINRA. Shagara painted very complex and daunting business problems, unstructured content, towers of structured data from unconnected systems, seas of internet information. Let's see how AWS Neptune helps us navigate these challenges. After loading the connecting all the data within Neptune, we were able to create multiple user experiences for our investigators. It starts with a search. Our users enter 2-3 entities they are looking for. That could be persons of interest, publicly traded companies, member firms, some stock symbols. Our UI then visualizes the found entities and draw connections between them. Now, note that it's important to simplify the presentation because your nicely put and created graph can become out of hand very quickly and turn into the scary hairball. It's important to make it simple to users to navigate that. So we use several techniques to deal with these challenges. So our UX uses filters, connected entities, timeline filters, some grouping, and also hiding irrelevant connections or entities. After displaying initial results, our investigators may decide to explore further. And this is where it becomes even more challenging because they add more entities and more connections to already complex picture. So what we do, we show to them how many new nodes and new connections are hiding behind the existing entities and connections. Now, after that, they can also enrich the graph with information from internet. They can connect it with additional external searches or additional external public knowledge graphs. As famous saying goes, trust but verify. Our users want to trace results presented on the screen back to the source. For unstructured content, we implemented view of the original documents with highlights for the search term or the data points from the knowledge graph. Users can now see the context where the entities of interest appear and mark a document as an evidence. There are times when we don't have all the necessary information to show on the screen. And in this case, we allow users to enrich the knowledge graph with information they found somewhere else. And we want this knowledge to be preserved for other investigators on the team. So we let through our UI our users to enter additional nodes, additional connections, so on, and some comments. We learned very quickly that there is no single way to present a knowledge graph. Some people look for hierarchical structure. Some people like the nodes and edges. Some people just like good old tables. So we licensed the framework and visualization library that allows us to pick any presentation that user wants. Now, let's look under the hood and get a better idea how AWS technologies enable for us such a rich experience. Knowledge graph is a connected data set. Connections are first-class citizens. Needless to say, how important it is to success of the knowledge graph to have the good amount of high fidelity and high quality connections. When building investigative knowledge graphs, we use numerous ways to harvest and infer connections. Many of those are driven by natural language processing, by machine learning experiences and libraries, and other AI-powered techniques. Our architecture may be logically split in two parts. The top portion shows the main way how we build the knowledge graph, and the bottom portion shows how we visualize this information and present it to the user. And right now, this architecture is built in a way that we can refresh our knowledge graph on a nightly basis. We have created multiple pipelines for structured and unstructured data that transform content and then stored to S3. From S3, we use Neptune bulk loader to hydrate our investigative knowledge graphs. This allows us, if needed, to reload knowledge graph in case of data quality issues or to produce another investigative knowledge graph. Transforming structured data to knowledge graph triples is an easy process. You just need to understand the semantics of structured content and build the corresponding transformations. It's a completely different story when you're dealing with unstructured content. We are dealing with documents that require optical character recognition. We are dealing with documents that are unstructured and freestyle documents. We are dealing with documents that are bank statements and other semi-structured documents. And this is where Amazon Textract comes to the rescue. Now, Amazon Textract allows us to identify and extract the important information from document images or other types of unstructured information. After that, we pass that to Amazon Comprehend, and it takes it even further to the next level. So Amazon Comprehend allows us to extract names, places, monetary values, and some other important to our regulatory mission entities. Our UI connects directly to Amazon Neptune, querying its content using Sparkle. It's flexible and has very reasonable performance and in response time. So we can implement even a life experience of navigating through knowledge graph.
Thank you, Dimitra, for that nice walkthrough of our technical journey. Now, what did we achieve at the end of this project? Remember, our challenge started because of the deluge of data that was overwhelming our investigators, who had to read through all the information to gather all the insights that they needed for their case. Using Textract and Comprehend, we can now automatically process all the thousands of documents that we gather as part of the case, extract information from it, and marry it with the transactional data. That automates a very laborious process. With the various data stores and number of systems that we have at FINRA and all the external data and external sites that our investigators have to go to for their research, it's impossible for one investigator to remember which data exists where. Well, they don't have to anymore. We can now gather this information spanning across a regulatory domain, extract all the relevant information, and present it to them. The quality of an investigation often depends on the experience of the staff, their dedication, their persistence, their knowledge. Now, when we give everybody a standard set of knowledge graphs to begin the investigation, we are raising the level of our investigatory powers. We are jump-starting their investigation from a higher level than we were before. And when our staff do not have to manually sit together and stitch that investigation board, they can really focus on the true knowledge work, digging into the graphs, finding all the obscure and hidden connections that are so difficult to find in conventional approaches, and finding new evidence that wouldn't have come to light otherwise. Essentially, AWS technologies are making us much more powerful investigators who will be better at protecting the investors. Now, all of this project wasn't all smooth sailing and didn't go smoothly right from the beginning. We learned quite a few lessons on our way. Once again, the power of the graph is about finding the trail, those connections and those right entities, which is where the qualitative entity extraction is really critical and requires significant investment and business knowledge to get it to the point where it's really useful. I would say that's a fine-tuning effort that people get better over time. Now, the power of graphs is about visualizing these connections the way human mind works, and which is why the UI design is extremely important. And we spent months on it with an expert UI designer, and we learned a lot of lessons by feedback from the end users. And also, remember, it's very tempting when such a new powerful toy is presented to us technologists to say, let's get all the data and show all the data because now we can do in a graph. But then we would be recreating the same delusion, overwhelming information that we started to solve with. So at every level of the graphs, it's important to remember, present the relevant information and then have the investigator and the end user decide where they want to go next. And in the end, it starts with the input data, the quality of it. And for us, many of our data sets required OCR, and we had to invest in improving the quality of OCR so that we get the right output at the end of it all. And finally, named entity recognition, figuring out who's John Doe and which is the bank statement and what is the account number is, of course, critical to tying it all together. And that's an area that's in continuous improvement. Amazon has made tremendous strides in it, and we continue to benefit from it. Now, this is one application of this set of technologies, including Neptune. We have plans to use it in other regulatory areas. And to tell us about our next steps, I'm going to turn it over to my colleague, Dimitro.
Thank you, Shigaro. So we just demonstrated the applicability of Knowledge Graph to investigating possible insider trading violations. One of the other exciting things we discovered is that, well, we can use that for several other business problems that bother our investigators at night. So let's briefly talk about the other opportunities. So market manipulation is another area we can apply knowledge graphs. Misrepresentation or material omissions and fraud. Trade allocation schemes, for instance, preferential treatment, inadequate anti-money laundering. That's actually, close relative of insider trading business problem. Now there are more. There are investigative and inadequate supervision of brokers selling away, and of course, inflating prices of shares. So you may ask, what are our next steps? We finished this effort, and we are very excited actually about our next steps. So what we would like to do next is we would like to leverage Neptune ML. And this is actually very exciting opportunity for us because not only we can now identify those violations, but we would like to now build patterns. So we cannot necessarily replace our seasoned professionals, but we can help them quickly identify those areas of concern. We would like to improve the dependency parsing methods when analyzing unstructured content. This is important for high fidelity, good quality knowledge graphs. We would like to use Amazon Comprehend custom AutoML capabilities because a lot of our content is unstructured and we deal with very diverse corpora. Amazon Comprehend events for financial events is in our cards, of course, because it helps better understand the financial documentation, and we are financial regulator. Amazon SageMaker can help us with building new custom models. Not always we finish our investigation inside the knowledge graph and visualization of that knowledge graph. Sometimes we need to export the data and run more analysis on top of it. And of course, the low-hanging fruit of integrating with Amazon Neptune full text search capabilities provided through Amazon ES clusters that would allow our investigators quickly locate people or organizations of interest. Thank you very much. Back to you, Blaise.
As you can see, knowledge graphs are a powerful tool to leverage your data and the relationships within it. In FINRA's case, they were brought a business problem by their investigators, and their investigators had already solved it and asked Shigata and Dmytro to basically leverage the data within their organization to solve the problem that the investigators were really testing them on. And they were able to turn out the same results and then take it one step further. And best of all, they could start to unlock the knowledge that was held within the stacks of documents and basically build a machine learning inference pipeline with Amazon Textract and Amazon Comprehend. And being able to take those documents, put them into triples, and then ultimately put them into a way that is consumable by Amazon Neptune, and then searched by their investigators. So I want to thank Shigata and Dmytro for really sharing their journey with us today. At AWS, we really love your feedback on our sessions, and we use it to continue to improve them. So please complete the session survey and let us know how you like the presentation, and I hope you have a great day.